All right, radicals. So our primary focus last year was switching from whole to mixed and mixed to whole radicals. And we didn't do as much work with the variables as you're going to have to do this year. Okay, so again, if I have the square root of 20, let's just do 28, let's say. Square root of 28. Okay, so that's a whole radical right now. I want to write that as a mixed radical. To write it as a mixed radical, I need a whole number and a radicand, which is just the square root. All right, so to do that, I want to find a value that goes into 28 that is a perfect square. Okay, it's not a number that's smaller than 28. It's a number that, when I say goes into, is a factor of. Right? So what number is a factor of 28 that is a perfect square? 4. And what do I times 4 by to get it?
7.
So I change that to square root 4 times square root 7. And what is the square root of 4? 2. So to rewrite that as a mixed radical or radicand, it's 2 square root 7. Okay? So this was our primary focus last year, is doing things like this. Then we had to take three square root 5, which is a mixed, and turn it into a whole. So how do we turn that into a whole? You guys remember? Say that again?
Square 3. Square 3.
Right.
And then
Square and square root 3. So I get it underneath the root. Okay, because these cancel out, so it still leaves me with 3. And then times it by 5. So that's square root 45. Okay? So far so good? All right. The number part was the easy part. Let's start looking at something less, not as difficult. So let's go. So I want to change that now to a whole or a mixed radical. Sorry, a whole radical. So I've got to use the same steps I just used. So what am I going to do? Square x, square root it, times that by square root of x to the 5th. Okay? What do I do with those exponents when I multiply them? I add them. So that's going to give me x to the 7th. Now let's take it a step further. What if I asked you to write this in exponential form rather than radical form?
Over,
Yes. Over.
over, I don't know, 8?
No. So what am I asking you to do? I want to rewrite this where I don't have the square root anymore. I have it written as an exponent. So I guess the question is, what is the square root as an exponent? What is the square root as an exponent?
2.
Then wouldn't it be x squared?
Oh, half. Yeah.
1/2. That's right. So that's what it is. So this is that there. Okay, you remember this from last year a little bit now? So now what do I do when I have a power to a power? Multiply them, so I get that, leave it in fraction form. Okay? So then what is this? Written in exponential form. AB to the 1/3, or that. Okay? So far, are we recalling this? Anybody not recalling this from last year? Okay, these, I'm just trying to take you through the very basics we're getting into. Now, what if I have this? And I want to write that as a mixed radical. I have to write that as a mixed radical.
Square root x
Say again?
like, cause you have to add the exponents, or it's not, I did like square root x three, and then square root x four, and multiply them.
Okay, it's not, you're not far off. Right.
X square root x to the fifth.
X to the fifth?
Like x to the power five.
And then x to the two. That's what I said.
X square root x.
That?
No, just remove the square root in front of the x. And the square.
Okay. So, well, basically you and I had the same thing. You had that,
Same thing.
and then you changed it to this.
Yeah.
Okay. You're on the right track, but not right. Okay, so you're very close. All right, so let's find out why you're not right. Well, let's say I took x to the 7th. Now, in order to get the square root of a number, that value has to be divisible by a half, because the square root is a power of 1/2, right? So here's what I'm going to do. There's a couple ways to do this question. One way is do this. Right? Does that give me 7? Yeah? Okay, so what's the square root of x squared? X, 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 square root of x. So what does that give me in front?
3x.
X times x times x.
X to the.
Fix it. So there's your actual answer for that. Okay, so that would be one way in which we can do it. All right, and if I had the cube root, so if I had this, the cube root of x to the 7, I would write that out as cube root x cubed times cube root x cubed times root x. Oh, cube root x, sorry. Okay, what's the cube root of x cubed? I have that, which is equal to x squared cube root x. So I'm finding all the powers of 3 that go into that, right? So that's one way to do it. Break it up. So because it's cube root, I want the cube root of x cubed, then the cube root of x cubed, and then that leaves me at the cube root of x. X to the third, x to the third, and x make x to the 7th. What's the cube root of x cubed? Just x. Cube root of x cubed? X. X times x is x squared. So I get that here. Okay? So those are the longer ways of doing it, but it makes, most of you will understand this better than what I'm about to show you. Alright? And that is this. This is the shorter, easier way to do it. I'll start with this. What is the largest number that 2 goes into that's less than 7? 6. So I'm going to change this to x to the 6 square root x. Everybody follow the question I just asked? Okay, what's the largest number that 2 goes into that's less than 7? That value is 6. So why did I ask that? Because what do I change that to? X to the 6 to the 1/2, right? I have to leave this as is. What's 6 times a half? 3. So I get x cubed square root x. Same thing as right there.
So
Okay? This is the easier way to do it. Just, okay, go ahead.
if that was x to the power 8 instead of x to the 7, you still do,
If this was x to the power of 8, 2 goes into 8, correct? So that's x to the 8 to the 1/2. So that's x to the 4th. Okay? Alright, now I'm gonna work with this guy now. So if I have the cube root of 7, what is the largest number that 3 divides into that's less than 7? 6 again, right? So I get cube root x to the 6th times cube root x, okay? Which is x to the 6th to the 1/3 now. Cube root x. What's 6 times a third? 2. X squared. Cube root x. Okay? That might be the easiest way for you to do these questions. You ask yourself, based on whatever root number you're talking, what's the largest number that value can go into that's less than it? So I'm going to go back to your example where you said this, cube root x to the 8. Okay? What's the largest number that 3 goes into that's less than 8? Still 6, right? So that's going to give me cube root x to the 6th, cube root x squared now. 6 times 2, or 6 add 2 gives me the 8. Okay? So what is this? X squared, cube root x squared.
So you just leave the second one alone?
Yes. If it can't be broken down, I leave it as is. Alright? This is the part that's going to get complicated for you. That's the part that I find the grade 11 struggle with, is this right here.
So to turn it back.
Yes, Mary? Sorry.
Sorry, I just don't get like how you get x squared from that.
Sorry?
I don't get how you got x squared from.
X squared? Okay.
Like
X to
that,
the...
the second one, like at the final answer.
Here?
Yeah.
I just leave it, because I can't break it down anymore.
No, like 3 root x 6. How
Oh.
did you get?
Sorry. Okay. That value is to the 1/3, right?
Yeah. Okay.
So 6 times a third is 2. So you get x squared. Okay? I did that up here, that's why I shorted it.
So if that was like an x to the power of 9 is 1/3, the answer would be x cubed.
Yes, that's the answer. Yeah. Okay? So again, there will be struggles. We know that. There were last year, there is every year.
So to take it back, sorry.
Sure.
So to change it back into like the normal, like back into what you started with, like the root 3, you would multiply the exponents together and then add.
No. You would change this to cube root and then cube it again. Okay. I'm going to answer Rory's question right now. How do I change this? Oh, sorry. I'll work it backwards. So I have x squared cube root x, let's say. And I need to change it into a whole radical. So I do the same thing that I've done before. I'm going to cube this and cube root it. That. So I add this and add that to it. What's 2 times 3? 6. So I put the cube root of x to the 6th times cube root x. X to the 6 times x is x to the 7. Add together. Okay, so it's the same process as the numbers. It just looks more confusing when I add letters to it. Okay? Alright, let's look at our examples in our book. So I want to change 5 root 2 to a whole. So I need to change it to a whole, so what am I doing? Squaring 5 and square rooting it. So what does that give me, square root? 75.
Oh, yeah.
25 times 3.
You can just go back to the other page just for a quick second.
Okay, example number 2 is that. So,
Square, two B squared. That's right.
so square root it and add the squared value to it under b, and then multiply them together. Okay, 2 squared is 4. B squared times b is b to the third. Okay, is everybody writing that down in your book? Follow through in your book. Okay, the last one.
Okay, I'm sorry, I have a question. So you got the 4 from the 2 squared? So that's how you got 4?
I have to square this. What is that? What's 2b times 2b?
2b squared. 4b squared.
4b squared.
And then you add.
So I got 4.
Okay.
And then b squared times b is b cubed. Okay? Alright, so what do I have to do here now?
Cube, 4, negative 4.
I've
And
got to
square cube again.
put that there as a cube root,
And then cube.
and then cube that. Okay? So that's going to give me this. What's minus 4 cubed?
60.
Negative 64. X cubed is x cubed. And the cube root of 7x squared. Okay. Does everybody know how I got here? Please ask if you don't, because I'm telling you right now, this is not going to go well if you don't ask your questions. You've been too quiet for too long. It's time to buck up here.
So how do you get to negative 64 again?
Negative 4 cubed.
So you still got the cube. Oh yeah, I see.
I have the
see.
cube for the
You
x,
took
but
Yeah.
negative 4 times negative 4 times negative 4 is negative 64.
Yeah, I see now.
Okay? And then the x cubed, so I just leave it as x cubed. Eli? Okay? Now I combine these. Negative 64 times 7.
148.
X cubed times x squared.
X to 6. Oh no, 5.
Here's your done. Okay? Mark, set, go. Hold on a second. Now go. Put it on the side of your page. Put it at the top of your page. Put it somewhere. How many of us got the first step? We got the first step? Okay, that's the key. Who did not get the first step? Eli, what did you do first?
I squared it.
Squared it?
Cubed it.
Okay, so you know why we cube it? Because of that guy right there.
So it has to be the same.
Has to be, absolutely. Has to be the same. Okay? If it's not, then you don't multiply them at all, but it has to be the same. Okay, so now, I'm gonna simplify this guy. That gives me 4 cubed, which is 64, and a cubed, which is a to the third. How many of us got there? Great. How many of us got the right answer? Who did not get the right answer other than Eli? Brittany, what did you do?
Well, the 4, I squared it instead of cubed it.
She had 16 instead of
Yeah.
64. Okay. Do you know why
Yeah.
it's, so it's 4 times 4 times 4, right? Okay. Galen?
I put 4 instead of 3.
Here?
Yeah.
Okay, you're not multiplying by anything. Once it's a cubed, it stays as is. Okay? All right? We're okay so far? Not bad? Yes, Shay?
If the 2 had an A, would it be A
To the fourth.
to the 4th?
Yes. Yeah, that's right. Okay, why don't we try one more? Let me finish it first and then I'll let you do it. Okay, go. Once you're finished doing this question, I want you to write out the first 12 perfect squares and the first 5 perfect cubes. Write it out. So the first 12 perfect squares and the first 5 perfect cubes. Once you're done. If you're still going, don't worry about it. Without the assistance of a calculator, preferably. Okay. Many of us got that right so far. That you put the 4th root and the 4th. Okay? Eli? Good? Okay, so you're already ahead of the last one, right? Perfect. Okay, so 4th root. What's 3 to the 4th? 81. And that's x to the 4th. That's 4th root 2x. How many of us got that right so far? Okay? And what's the last step here? Gotta multiply it, right? So that gives me the 4th root of 162, x to the 5. That's right, that's it. Okay, how many of us got it right? Okay, that's great improvement. Okay, it's a great improvement, that's good. So that's the first major that you gotta get through, is we gotta get through this guy right here. If you can now do this, that's huge. Okay? So, let's look at the second part. Now, before I go, let's discuss what are the first 12 perfect squares, because we need to make this unit go easier, we need to recognize those numbers quickly. Because when we're doing factors, it helps to know what those numbers are. So I've got 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, 144. You need to nail those. Okay? First 5 perfect cubes. 1, 8, 27, 64, 125. Okay? So if you still struggle with those, put them somewhere where you can see them quickly. Alright? Now the reason I'm doing that is because I want to break this down now. 192. So 192. I need to change that into either a whole number or a whole number and a radical. Again, so somebody give me what you think the largest possible number is that goes into 192 that's a perfect cube. Or sorry, perfect square. Perfect square.
69.
Come again?
Wait.
No, see you, I just,
No,
this is doing the same thing that I said to Rory. When I say goes into, doesn't mean smaller than. Means divides into. So what is the largest perfect square that divides into 192? Go ahead. 64. And what do I times 64 by to get to the square root of 192? Times it by 3. Okay? So the answer then is 8 root 3. Okay? Now, let's say we can't find 64 easily. So try a different perfect square. What is another perfect square that probably goes into 192? $16 does? Okay, so take 192 and divide it by 16. What do you get? Sorry? 12. All right, so that's okay. That's okay, that's a good start. Again, the point of this would be to not use your calculators, but I understand our skills are lacking, so when it comes to factors, so you're going to use your calculator a little bit to speed things up. So I get that. So that's 4 square root 12. Is there a perfect square that goes into square root 12? What is it? 4. So I can change that to 4 square root 4 times square root 3, right? 4 times 3 is 12. What is the square root of 4? 2. Square root 3. 4 times 2 is 8. 8 square root 3. So you can still do this. If you don't know what the largest number is that goes into 192 evenly, that's a perfect square, you can just keep breaking it down until you can't break it down anymore. And still end up with the same answer. There it is. Okay, so that can be done. Alright, because I haven't done this for a couple minutes, I'm going to do it again. Cube root y to the 7. You guys go. You guys go. What is the cube root of y to the 7? Remember the question that I asked you that led you to the answer. What was the question that I asked you that led you to the answer? Anybody want to say it? Do we remember it?
Yeah.
Go ahead, Roy. No, just tell me what the question was that I asked you.
How many times does 2 go in without, what's the largest multiple of 2 without going over 7?
Want 2. Is it right? It's 3, right? Because of the cube root.
Yeah.
Okay, good. So what's the largest value of 3? Sorry, the largest factor of 3? Or the largest number that 3 goes into that's less than 7? 6. So I'm going to rewrite it as cube root y to the 6th, and how much is left over if I take y to the 6th out of y to the 7th? 1y. Okay? So what am I left with then?
Y squared, square root of
Cube root
cube root.
y. Okay? Juice?
How did you get the y squared? Oh yeah.
Okay, the exact same question Mary asked.
Yeah, I understand more of that.
Okay, that's fine. I like it then. I would change it to that. I just skipped that step. But yes, if I was to do, I would do it like this. Eli, this is the way I would do it. That's the way I would do it, for sure. Okay, if I have any issues with this and I can't see it, then that's the way I would do it.
So would it be wrong if you wrote y squared, y to the power of 1/3?
No, but if they're asking for
Your
you,
bases are the same.
but if they're asking you to put it into a mixed radical, then yes, it's wrong. A mixed radical means that I have to have a cube root. If you were working with powers, then I would have changed it to y to the 7 to the 1/3 here. And then it would have been y to the 7 to the 1/3, y to the 7 over 3. So if I was asking you to change it to an exponent only, this is what I would do. But I asked you to change it to a mixed radical. Okay? Any questions about this? Do you want to do another one like this? Yeah, okay. All right, you go ahead on that one. Okay, what's the question we asked? Pardon me? Yeah, you can ask that question. That's okay to ask it that way. How many times does 4 go evenly into 11? Goes into it twice, right? Because it goes into 8. So that's one way to ask it. I prefer, what's the largest number that 4 goes into that's less than 11? What is it? 8. So I change this to 4th root x to the 8 times 4th root x to the 3. How many of us got that right? Okay, Eli, no?
Yeah, I never did the x to the 3.
Okay, so whatever I take out of here, it's x to the 8th, whatever I'm left with has to go in that last bracket, that last root. Okay? So now, I have x to the 8th to the 1/4. How many of us got that far? Good. Shay, did you get that far?
No, I didn't do 1/4, I did 1/3.
Oh, you did 1/3 by accident. Okay, so that's an easy fix. So that's okay. It's not that you don't know, it's just a mistake. Anybody else not get there? Okay, who didn't? Alright, 8 times 1/4 is what? So I want to x squared times 4th root x cubed. There's the answer. How many of us got there? Okay? Okay, alright, go ahead.
So if I, like, if you ask the question, like, how many times does 4 go in evenly, can you just put a 2 down for like x to 2 and x goes left over?
Mm-hmm.
Can I do that instead of doing all that?
Yes. Yes, you can. Yes,
Is there ever a time then that you can simplify the second result?
no, because you're taking the largest possible whole number out
Yeah.
that it can go into. So that's always what's left over. So it's like this, okay? Square root 50. I need the largest perfect square that goes into it. That's 25. I can't take anything out of 2, it's gotta just stay as 2. Right? So this would be 5 root 2. So it's the same thing. Okay? Alright, any questions about that? Alright, we have one last thing to look at then, and that is this. First of all, what does 3a add 4a equal? 7a. What does 3a add 4b equal? Yes. I can't add apples and oranges, can I? Alright, you can't add them if they're not exactly the same, we all agree? Okay, good. What does 3 square root 2 plus 4 square root 2 equal? Very good, Isaac. 7 square root 2. I treat those the same. I don't switch apples to oranges up here, so I don't do it here either. Once you have that square root number, and you've got it as a radical and it can't be broken down anymore, it stays as is. Alright? So what if I ask you to add this? What does that equal? Exactly the same. I can't do anything with it. If those two values are not identical, you can't add them together. You get that? Okay? So you learned this in grade 9. In grade 10 we did some of this. You can't add them if they're not identical square roots. And you break all your square roots down until you find out what they are before you add them together. Alright, so look at example 4 in your notebook here. 192. I have square root 27 plus 2 square root 12. Hey, can I add them together like that? No, because the square roots aren't the same, right? So now my next step then is, can I break them down? Can I break down square root 27?
Yeah.
Okay, what is it? Is there a perfect square that goes into 27? 9 does? So what do I times 9 by to get 27? Okay, good. Get this. How about square root 12? Is there a perfect square that goes into square root 12? And what do I times it by to get there? 3. Okay, great. What is the square root of 9? 3. So I have 3 square root 3 plus. What is the square root of 4? 2. What's 2 times 2? 4. So I get 4 square root 3. So I asked you the same question I just asked on the last board. What is 3 square root 3 plus 4 square root 3? 7 square root 3. Okay? It's not that difficult. And if it doesn't match up exactly, you don't add it, you just leave it. Alright? Following this so far? Okay, let's look at the next one. I have is 5 square root 8 minus 3 square root 18 plus square root 3. Okay. Is 8 a perfect square? No. Is there a perfect square that goes into 8? What? 4? And how many times? Is 18 a perfect square? Is there a perfect square that goes into 18? That. Okay? Root 3 has to stay as is. Alright, square root of 4 is? 2 times 5 is? So that's 10 square root 2. Right? Square root of 9 is? 3 times 3 is? 9 square root 2 plus square root 3. Okay, can I break down the square root of 2? Can I break down the square root of 3? There's no longer any perfect squares that go into them, is there? So I've got them broken down as small as possible. Now, I collect my like terms. 10 square root 2 subtract 9 square root 2 is what? 1 root 2. Can I add that to root 3? There's my answer. Second. Okay? That's how I leave it. As soon as I've got them broken down into the smallest possible square roots, I add them together to the point where I can't add them anymore. Alright? Ask your question.
So when you're breaking down 5 square root 8, the input is the first square root you put.
I do because it ends up being the whole number. Right? You could put it over here. It wouldn't matter because it's still multiplication. 3 times 4 and 4 times 3 is still the same thing. But I always set it on the front because if there is something I have to multiply it by, then I see that.
So then how do you know which one you get 10? Like,
Pardon me?
how did you get 10 square root 2 from there?
This is 5 times square root 4 times square root 2, correct?
Yeah. Oh,
What's the square root of 4?
2 and then
5 times 2 times root 2 is 10 root 2.
I see. That's just,
So I multiply my whole numbers by whole numbers, and I multiply my roots by my roots, but I can't multiply them together. Does that make sense?
yeah.
Anybody else have a question? Yeah, Brittany, go ahead.
Does the 1 have to be there or no?
No, it doesn't.
Okay.
It doesn't. I just wanted to show you that it was there. Any other questions? You're doing really well today. It's been a long 15 minutes already, and you guys are still engaged. I got one more to do, and then I'm going to let you work. Okay, 3 square root 32a minus 4 square root 162a. Now, first things first. If you look in your book, it has something, a notation beside this. And it says that a has to be greater than or equal to 0. The reason they put that in is you can't have a negative number in a square root. So a represents any number. So we have to say, in order for us, like if we were to solve using this method here, like if we were to solve it, we'd have to understand that a can't be a negative number. We all agree? Can't have the square root of a negative number. So what they do is they write the restriction down as this. A has to be greater than or equal to 0. It doesn't matter if there's x, y, z, whatever's in there. It all has to be a positive number or 0. Okay, so that's what they write down. Alright, so let's do the same method that I did before. I got 3 again. Square root of 32. What is the largest perfect square that goes into 32? 16 does? Okay, so I'm going to rewrite that as square root 16 times square root 2. Can a be broken down? with the square root? No, it can't, so I leave it like that. And I'm doing all the steps here. I wouldn't do this personally, but I'm gonna do all the steps so you see them all, okay? All right, now we gotta look at 162. What's the largest perfect square that goes into 162? 81 does? Awesome. How many times does it go in? Twice? Okay, and square root A can't be broken down, right? I'm gonna rewrite this last guy right here, sorry. As square root 2A. Okay, so I'll get back to this in a second. I'm just showing you, I shortened one of them, and one of them I wrote everything out. All right, what is the square root of 16? 4. 4 times 3 is 12. Square root. Square root of 2 times the square root of A is still 2A. Subtract. What is the square root of 81? 9. What's 9 times 4? 36. Square root 2A. Are my square roots exactly the same right now? Yeah. So can I simplify this then? What does it simplify to? Hold on. Negative 24 square root 2A. Okay? Questions about it? You're all right, it's not that bad. Okay, any questions about it? Yes, Mary?
Sorry, I kind of got lost on the third row there.
Right here?
Yeah.
Okay, so the square root of 16 is? So 4 is a whole number, right? So I can times it by that whole number, which is 3.
Why would you times it by that? Why would you times it by that?
I'm multiplying my whole numbers by my whole numbers and my roots by my roots.
No, I realized.
You okay? So that was 4 times 3, which gave me 12. And root 2 times root A is root 2A. 4 times 9 gave me 36. You're good? Okay. Yeah? Any else? Questions?
Actually, when you're doing the square root of 16 is 4 and multiplied by 3, I get that. But 4 is a perfect square root also, and it can be broken
Yeah, but
down.
you already got it as a whole number. You've lost the square root now.
It doesn't matter. It can be broken
Look at
down.
it. If I ask you what the square root of 9 is, what is it?
3.
Does the square root exist anymore? So then you're done. Does that make sense? Okay, once you've taken the square root of a number, the square root no longer exists. It's just a whole number now. Okay? It stays as a square root if it's not something I can break down. Alright? Any other questions about this question here in particular?
So if you were to multiply it, you were to change everything and then back, you would just multiply 12 by 36 at the end?
No, there's a subtract there.
I know, but if it was multiplied.
Oh yes, then yeah. Yes, you would.
Okay.
Yeah.
And then
Here, let me show you. Okay, let me answer your question like this. Okay? 4 square root A times 3 square root B. So A and B both gotta be greater than or equal to 0. And I want to put them as a single radical. So I times the whole numbers together. So 4 times 3 is 12, and then I times the square root guys by themselves.
Everything back to, I think they had, like, if they were the same bases, would they be, would they, like, if that was A and
Okay,
A would be.
hold on.
So before I start.
Yes.
Yeah. Or 12A squared.
Yeah, but then you would get rid of the squared. Okay, so I would have 12 square root A squared. Well, what's the square root of A squared? So it would actually be 12A. So that's actually not a terrible question to ask. That's exactly what would happen. Okay, you would end up with all whole values then. Okay? Anybody have questions today? All right, yes,
Is there any way to check on your calculator, just say if you do, to do like the square root of 50?
well,
and-
yeah, I mean, take 25 times the square root of 2, or 5 times the square root of 2, and
Right,
it would have to give you the same as the square root of 50.
when I do that, it's not. Okay, yeah, I was doing the other way where on the calculator it's like that second function button, or is that something different? Oh, okay.
Don't know, yeah, I don't know. Your calculators, no, I'm not sure. Okay, that was an hour. You have all day today, all 15 minutes of it, and all of tomorrow to do 5.1. Okay, so it'll be due for Monday, so I need you to work on it.
I have a question. Sorry.
Just let me shut the camera
Thanks a lot.
on. Okay, here's the water.